Okay, now, but the company decides not to pay back the loan in periodic payments to the bank. Instead, they negotiate a loan payment of one lump sum. So they're going to pay back bank the $400,000 in one lump sum. Because of that, they get some interest rate things. So instead, they're going to take a sinking fund, and they want to know, can a sinking fund or a future value annuity give us $400,000 to pay bank in one lump sum at the end of 5 years. So what am I do with, so my future value, this is what I desire, is to get $400,000. But instead of paying the money to the bank, I'm going to put it in periodic payments in an annuity. So I'm not going to give it to the bank. I'm going to put it in an annuity. So same things apply. End of each payment. T is 5 years. R is 0.09. And M is 2. So in this case, once again, I want to find R. But this in case, I use a future value equation. Divided by R over M. So in this case, this is R, not P. S is 400,000. R is what I want to find. 1 plus 0.09 over 2. Now it's positive. 2 times 5 minus 1 divided by 0.09 over 2. So once again, 400,000 equals R. And we pretty much have the same basic data. Well, let me go to my calculations. Here's the number 6. Okay, here we go. And it's 1.045 once again. 1.045. Sorry. 1.045 to the 10 minus 1 divided by 0.045. So I'm not going to go through all the calculations, but when I do this, I get 12.29 times R. So R times 12.29. So R equals 400,000, 12.29. And when I do that, I get 32,540 per period. 547. That's every 6 months, right?
Yeah, M equals 2.
Yeah. So notice that my payment is different from the loan. The loan was $50,033, and that I paid to the bank. This is actually coming to me because I'm putting money in. Okay, so this is an annuity coming to me, basically. So let's see what my payout is here. Let's compare it. So now I'm looking at from the sinking fund. So from the sinking fund, well, what's my total payout? Well, that's RMT again, right? That's going to be 32,547 times 2 times 5. So my total payout, which I calculated here, is 325,470. Now this is what I generated. This is my payout, but this gave me 400,000 after 5 years. My future value. So what did I save here? Look at my savings. I just paid out 325,470, but that's going to generate in the future. So this is going to be my balance in my annuity at t equal 5. So what did I save? My savings is 400,000 minus 325. So my savings came out to be 74,530. Now that's just the sinking fund. Of course, a lot of that's going to go back into interest. But look what I saved by not putting it into the bank. I would have had to pay the bank $106,000 to $320. Okay? Basically, I saved money, which is going to go back to the bank. So I used the sinking fund to pay the bank in one lump sum. So I pay back the bank in one lump sum. There I paid back the bank periodically, and the bank got the money. This money actually came to me, but then at the end I had a balance of 400,000, which went to the bank. But it only cost me 325. That was my cost. So that can tell you why companies will go into a sinking fund. And of course it depends on, here we assume that the interest rate was the same in both. That may not be the case. In other words, sometimes the interest rate might be lower here, and this might not be the same advantage. But in this case, it does. So notice, one case, I'm looking for a future value of 400,000. In another case, I'm looking for a present value of 400,000, finding out how much I pay out. So this is a future value problem. So write down a sinking fund is always a future value problem. Okay? So you know it in the future. Okay, last one on the test. Number 7. By the way, you didn't have to do this on that problem. You just had to do the sinking fund. But a lot of people don't understand what a sinking fund is, so I figured I might give you a comparison. Once again, remember the interest rates, the compounding periods were the same. Okay, so number 7. Let's see what number 7 says. Suppose you invest $100, so it's $100 per month at the beginning of each month. All right, so what are you given here? So your other givens, plus percentage given. So R is 100. So here's the periodic payment. So right away you know you're in an annuity. There's no compound interest. There's no simple interest. All right, it earns 6.9% or 0.069. And it's compounded monthly, okay? So M equals 12. But now look, it says at the beginning. When you pay at the beginning, and it's in capital letters, you have a future value annuity due. So let's look at the future value annuity due problem. And I think you guys, it might have been my fault, but you got confused. I didn't take off of this. But that's going to be the future value 1 minus 1 plus R over M. Oh, we're doing the future value. This is present value. My fault. Oh, geez, you're kidding me. Okay, so S equals R. 1 plus R over M. MT minus 1 divided by R over M.
There's another eraser on the shelf there for you.
Wait, is there?
It was behind the
Oh, good. Okay. But that's not this is the payment at the end of the month. So this is called an ordinary annuity. A lot of you use this, and it's not true, because with an ordinary annuity, you pay at the end of the month, or end of the period, whatever the period is. Now, for an annuity due, this formula is the same, but we have to tack on an appendage. There's an extra time. Now this is divided by R over M. For some reason you guys read it as this being in the denominator. It's not. Write this down. And in the future I'm going to give you another reference table which is easier to read. The appendage R plus the extra period is in the numerator. So in this case, we want to find future value. So you want to find S. So S equals, R is 100. 1 plus 0.069 over 12 times 12. And what's the time period here?
M equals 12, it says. Oh, but you know T.
Okay, what is T? Let's see. 5.5 years. That's going to be minus 1 times 1 plus 0.069 over 12. That's the appendage. Now the whole thing is divided by 0.069 over 12. All right, let's do... I have all this calculated, so it's a lot easier. Where are we? Here's number 6, number 7. Okay. So here is number 7. All right.
Our coming right about 15 minutes too.
Okay, so that what's this? The third 15 minutes?
Correct.
All right. So is it 15 now? We have more time.
We have like 10 seconds.
All right, so we're gonna wait, and I'll be back.